Welcome to the Copperfield Electric Podcast, and welcome to you, our listener, to today's deep dive.
Glad to be here.
So imagine this. You just bought an $80,000 electric vehicle. I mean, it is a total marvel of modern engineering.
Oh, absolutely. It's basically a supercomputer on wheels.
Exactly.
Yeah.
Capable of doing 0 to 60 in like under 4 seconds. It's packed with silicon chips wrapped in this beautiful aerodynamic shell.
Yeah.
And you bring this masterpiece of the 21st century home, you pull it into your garage, plug it into a standard wall outlet, and realize something terrible.
That it's going to take 14 hours just to get enough juice to drive to the grocery store and back.
Yes. It's completely brutal. The future of transportation has just collided head-on with the reality of residential electrical wiring.
It's a profound bottleneck, really. We have automotive technology advancing at this exponential rate, but it's completely outpacing the physical infrastructure of the average home. I mean, most homes were built decades ago.
Right, which brings us to our mission today, bridging that gap between the car's capability and the home's infrastructure. Because EV adoption is skyrocketing, and we are seeing homeowners make well-intentioned but incredibly costly and frankly dangerous errors when setting up their charging stations. Okay, let's unpack this.
Sounds good.
To save you from those expensive missteps, we are pulling from a highly practical April 2026 article by Renee Hernandez. It's titled, Safe and Efficient Home EV Charging, Avoiding Costly Mistakes.
A great piece.
It really is. And we're pairing that with the real-world service portfolio of Copperfield Electric. They're a top-rated, family-owned electrical contractor in Southern California, so we can see how these theoretical mistakes actually play out on the ground.
Yeah, blending the architectural theory from the Hernandez piece with the operational reality from an active electrical contractor gives us a much more complete picture of what is actually happening inside people's garages.
Let's start with the most immediate point of friction, which is the hardware itself. The Hernandez article points out that many buyers overlook charging speeds entirely, like mistake number 1 and number 5.
Right, they just don't think about it.
They bring the car home, unbox the basic level 1 charger provided by the dealership, plug it into a standard 120-volt outlet, and just expect the car to be ready by morning.
What's fascinating here is the absolute limitation of physics. People don't realize that a standard 120-volt household outlet is designed to deliver roughly 1.4 kilowatts of power.
Which isn't a lot.
No, it's meant to run your television, maybe a blender, or a vacuum cleaner. Now, consider that a modern electric vehicle battery can hold anywhere from 70 to 100 kilowatt hours of energy.
Wow.
Yeah. So if you were dripping 1.4 kilowatts into an 80 kilowatt hour battery, you're looking at over 50 hours for a complete charge from zero.
Buying a high-performance EV and running it on a level 1 charger is honestly like buying a high-performance sports car and trying to fill the gas tank with an eyedropper.
That is exactly what it's like.
We know it's incredibly slow, providing maybe 3 to 5 miles of range per hour. So it means if you have a typical 40-mile daily commute, you are operating at a continuous deficit.
You plug it in at 7 at night, leave it at 7 the next morning, and you've barely replenished what you burned the day before.
Right, and that operational deficit just compounds.
Exactly. By Thursday, you're suffering from severe range anxiety. This is why Hernandez argues that upgrading to a level 2 charger isn't a luxury accessory. It is a fundamental requirement for the vehicle to function as a seamless part of your daily routine.
Because it bumps up the voltage, right?
Yeah, a level 2 charger utilizes a 240-volt connection. By doubling the voltage and significantly increasing the amperage, you jump from delivering 1.4 kilowatts to delivering up to 9.6 or even 11 kilowatts of power.
So you transform that eyedropper into a fire hose.
Exactly, giving you up to 30 miles of range per hour of charging.
Okay, but once you upgrade to those faster charging speeds of level 2, you're fundamentally changing how electricity flows through your house.
You are.
The bottleneck is no longer the charger, it's your home's electrical panel. And the Hernandez article makes it very clear. Mistake number 2, your electrical panel must be able to support this massive added consumption, otherwise you risk severe safety hazards.
This is where things get serious.
But I want to push back on behalf of you, our listener, because there's a common perception out there. People assume that when a contractor says you need an electrical inspection or a panel upgrade for your EV charger, It's just a sneaky way to upsell a bigger project.
I hear that all the time.
Right. Why can't I just buy an adapter online and plug my car into the 240-volt outlet I already have for my clothes dryer?
That is the most persistent misconception in the EV transition space, and it ignores the critical difference between an intermittent load and a continuous load.
Okay, break that down for us.
Let's look at the mechanics of your electrical panel. It basically acts as the central traffic controller for your home. It takes the main power feed from the utility grid and distributes it to individual circuits. Most older or standard homes have a main panel rated for 100 or perhaps 200 amps in total.
And a house is already drawing heavily from that pool of amperage, right? You have your central air conditioning pulling 30 amps, an electric oven pulling 40, a water heater pulling another 30.
Correct. The system is heavily allocated already. Now return to your clothes dryer analogy. Yes, a dryer uses a 240-volt circuit, pulling maybe 30 amps.
Right.
But a dryer is an intermittent load. The heating element kicks on, the drum tumbles, the thermostat hits its target temperature, and then the heating element shuts off while it continues to spin.
Oh.
It cycles on and off, allowing the wiring and the breaker to physically cool down. An EV charger, however, is a continuous load.
So it's just holding the throttle wide open.
For 8, 10, or 12 hours straight.
Yeah.
Yeah. When you plug in your car at 40 amps, it demands that peak flow continuously. The physical reality of electricity is that resistance creates heat. Pushing maximum amperage through wires, terminal connections, and breakers generates sustained thermal loads.
And historically, residential electrical systems were never engineered to pump high-density fuel into vehicles for 12 consecutive hours.
Never. The wires physically heat up behind the drywall. The connections expand and contract, and the bimetallic strip inside your circuit breaker, which is designed to flex and trip when overheated, is subjected to extreme stress.
So if you attach a continuous 40-amp EV load to an aging, heavily loaded panel without doing proper load calculations,
You aren't just going to trip a breaker and lose power. If a connection is loose or a breaker fails to trip, that sustained heat builds up until the insulation actually melts.
oh my God.
That is a literal catastrophic fire risk.
Here's where it gets really interesting. Once you understand the sheer physical heat and continuous electrical pressure we're talking about, the idea of doing this yourself becomes terrifying.
It should be.
The Hernandez article points out that poor installation practices in DIY projects are major issues. It is incredibly tempting to watch a 10-minute video online, buy some thick gauge wire from the hardware store, and think you're saving a few $100s.
A huge mistake.
But doing your own high-voltage, continuous load electrical work, it's like trying to do your own amateur dentistry or plumbing your own high-pressure water main. A tiny mistake doesn't just mean a minor leak under the sink. It means flooding your entire foundation.
That analogy perfectly captures the scale of the consequence. With amateur electrical work, the flood is an electrical fire. DIY installations frequently suffer from incorrect wire sizing, improper torque on the terminal connections, and severe code violations.
Which Hernandez warns about.
Right. The Hernandez piece explicitly warns about unexpected costs down the line, and the biggest one is insurance liability. If a fire originates from an unpermitted amateur EV charger installation, your homeowner's insurance policy will very likely deny the claim.
Wait, really? So you essentially void the financial protection on your largest asset to save a few dollars on installation.
Exactly, which completely undermines the perceived savings. This is why certified technicians are not just recommended, but non-negotiable.
And this brings us to the Copperfield electric source material. They are a family-owned, 24-hour electrical contractor covering a massive footprint across Southern California, specifically throughout Orange County.
Yeah, looking at their service model provides a perfect template for what professional intervention actually looks like.
Because Copperfield operates across such a vast area. I mean, they serve Irvine, Costa Mesa, Anaheim, Santa Ana, Mission Viejo, Newport Beach,
Tustin, Huntington Beach.
Orange, Fullerton, and Laguna Beach. I mean, they are everywhere in the OC. So their emergency teams see the real-world fallout of these overwhelmed panels and DIY attempts every single day.
They do.
When they dispatch for an EV charger installation, they aren't just bolting a plastic box to your drywall. They are performing those crucial load calculations to ensure your panel has the physical capacity for the continuous draw.
The product a professional contractor provides isn't actually the hardware. It is peace of mind. Copperfield prides themselves on being honest electricians. They emphasize that their teams are fully licensed. Their license number is 1094740, bonded, insured, and background checked.
Which is huge when someone is working inside your home.
Absolutely. When you introduce a high-voltage system into your house, you need the absolute certainty that the local building codes are met, that the wire gauge can handle the thermal load, and that the main breaker won't fail when you run your air conditioner and charge your car simultaneously.
And the importance of 247 emergency support cannot be overstated here. Continuous EV loads often fail or trip breakers in the dead of night after running for several hours.
Yes.
If your panel starts smoking at 3 in the morning, having a company with a 100% satisfaction guarantee that actually answers the phone, you can call them at 626-622-9694 in the middle of the night. That's a massive safety net.
It mitigates the long-term risk completely. You know that if a problem arises, a specialized professional is always available to handle the high-voltage infrastructure.
Okay, so let's assume you've set up the infrastructure perfectly. You skip the slow level 1 charger. You realized your home's panel needed an upgrade, and you hired a trusted professional team to install a level 2 system with the correct permits.
The ideal scenario.
Right. Now we look ahead. The final mistakes highlighted by Hernandez, specifically, mistakes 4, 6, and 7 all revolve around the long game. Not planning for future needs, underestimating your electricity costs, and skipping maintenance. Let's talk about future-proofing first.
If we connect this to the bigger picture, the transition to electric vehicles is rarely a single vehicle event for a household. It is a complete fleet transition over time.
Oh, that makes sense.
You might purchase an electric commuter car today, but in 3 or 4 years, there is a high probability your household will add a second electric vehicle.
And if your contractor only installed a wire and breaker sized exactly for 1 charger, maxing out your upgraded panel, you've backed yourself into a corner. When car number 2 arrives, you have to tear open the drywall and upgrade the system all over again.
Anticipating future demand is a hallmark of professional installation. To future-proof the home, a forward-thinking electrician will often install a sub-panel in the garage, or at the very least, run oversized electrical conduit.
Can you break down how a sub-panel actually helps in this scenario? I think a lot of people get confused by that.
Sure. Think of your main electrical panel as the central power plant, and a sub-panel as a local substation situated right where the demand is highest. In this case, your garage.
Yeah.
Instead of running multiple individual thick wires all the way through your house from the main panel to power a second charger later, the electrician feeds one heavy-duty line to the garage sub-panel now.
Ah, I see.
That sub-panel then acts as a local distribution hub, providing plenty of easily accessible circuits for a second charger, heavy garage tools, or battery storage systems in the future.
So you pay a little more for the robust infrastructure today to save thousands in demolition and rewiring tomorrow. That makes total sense. Now, speaking of saving money, we have to tackle the daily operational costs. The Hernandez article warns that while charging an EV is fundamentally cheaper than buying gasoline, a major mistake homeowners make is completely underestimating the monthly electric bill due to unplanned charging habits.
The economics of residential electricity have become incredibly dynamic, primarily through time-of-use rates.
Yeah.
In places like Southern California, utility grids face immense strain in the late afternoon and early evening.
Right. Everyone comes home from work, turns on their air conditioning, starts cooking, and turns on the television.
The demand spikes, so the utility company charges surge pricing for electricity during those peak hours.
Exactly. So if you pull your EV into the garage at 6 o'clock in the evening and immediately plug it in, your car is demanding a massive continuous load at the exact moment electricity is at its absolute most expensive.
Which is a terrible idea financially. Over a month, this can double or triple your anticipated charging costs.
Which is where smart charging hardware comes into play. You still physically plug the car in when you get home, but you program the level 2 charger to delay the actual flow of electricity until off-peak hours, say 1 o'clock in the morning, when grid demand plummets and the electricity is significantly cheaper.
It allows you to leverage the cheapest possible energy without changing your physical routine at all.
But here's something that caught me off guard. The Hernandez piece also mentions that these smart chargers require routine maintenance, specifically software updates.
Yes, they do.
Hold on, my wall charger needs software updates. I mean, it's a plug, not a smartphone. Why does a plug need an update?
Because modern EV charging isn't just a physical connection. It's a smart energy ecosystem. This isn't just a one-way street of electricity flowing from the wall into the battery. It's a two-way street of data.
Really? What kind of information is the car actually sending back to the charger?
It's a highly complex negotiation. When you plug the charger into the vehicle, before a single electron of high-voltage power flows, a digital handshake occurs.
A handshake.
Yeah. The vehicle's onboard computer communicates its current state of charge, the maximum amperage its internal systems can safely accept, and the thermal status of its battery pack.
It's essentially telling the charger its physical limitations in real time.
Yes. Simultaneously, the smart charger communicates its own thermal limits and the maximum power available from the home's grid. They negotiate a safe, optimal charging rate using specific software protocols.
That's wild.
And as new electric vehicles hit the market with different battery chemistries, and as utility companies introduce new smart grid features like allowing your car to feed power back into your house during a blackout, the software protocols change.
So if you ignore the software updates on your home charger, you are basically forcing it to speak an outdated language.
Exactly.
Eventually, it might fail to recognize the thermal limits of a new vehicle, or it won't be able to interface with the utility company's time-of-use pricing signals.
Outdated software becomes an invisible bottleneck. It degrades the efficiency and safety of the system just as surely as an undersized wire would.
So, what does this all mean for you? If we synthesize the hard lessons from the Hernandez article and the operational reality of experts like Copperfield Electric, it all comes down to treating your home EV charger not as a simple appliance, but as a fundamental, high-voltage upgrade to your home's critical infrastructure.
Beautifully said.
Do not settle for the agonizingly slow Level 1 eyedropper. Acknowledge the physical limits of your home's electrical panel and understand that upgrading it is about preventing catastrophic heat buildup, not contractor upselling. Avoid the amateur plumbing of DIY electrical work and let vetted, guaranteed professionals ensure the system is up to code.
Absolutely.
And finally, plan for the long game. Build a sub-panel for the future, leverage smart software to avoid surge pricing, and keep the data flowing as efficiently as the electricity.
Ultimately, managing an electric vehicle at home requires a shift in how we view our domestic energy consumption. And this raises an important question, which actually connects beautifully to the frequently asked questions listed at the end of the Hernandez article.
Oh, you mean the FAQs discussing the longevity of these systems and how we manage battery health?
Precisely. Hernandez mentions the 80-20 rule for EV charging. To optimize the chemical lifespan of the vehicle's battery pack, owners are generally advised to keep the charge between 20% and 80% for daily driving.
Right, avoiding 100% charges unless absolutely necessary for a long trip.
Exactly. But the FAQs also point out that the physical home charger itself has a definitive lifespan. The internal contactors experience thermal cycling every single night and will eventually wear out.
Right, I mean, it's hardware, it degrades.
So here's a final thought for you to mull over as we look to the future. If the home chargers bolted to our walls have a definitive, relatively short physical lifespan due to extreme thermal cycling, and we as drivers are heavily relying on strict mathematical parameters like the 80-20 rule to micromanage our vehicle's battery health over the long term, how will the physical architecture of our residential garages need to evolve in the next 20 years?
That's a great question.
Will homes eventually need to be built with integrated, liquid-cooled, commercial-grade electrical substations just to keep up with the demands of our driveways?
It really makes you wonder if the garage of the future will look more like a server room than a place to store tools. But for now, as we navigate this transition, if you need to bring your home's electrical capacity into the present safely, let the pros at Copperfield Electric take care of the lights. Because when you finally park that cutting-edge vehicle in your garage, you shouldn't have to worry about filling it with an eyedropper or burning down the house while you try. Thank you for joining us on this deep dive.